Good day to you, wherever you're watching me from. In this video, I will want to explain the hypothesis testing, and we will cover a range of topics, including what alternative hypotheses are, what null hypotheses are, what is a one-tailed test, what is a two-tailed test, and how to test for hypothesis. And I'll be happy if you like and subscribe to this video and other videos on this channel. Basically, in this particular video, I would love to explain to you in this video the concept of hypothesis testing, as it were. So let us start. So at the end of this lesson, one of the things that I anticipate is that you should be able to understand define hypothesis testing. You must be able to understand how researchers use statistical procedure to make decisions about population based on sample data. Number two, you must be able to distinguish between the null hypothesis, which is saying no effect, and the alternative hypothesis. Number three, you must be able to explain the one-tailed test and two-tailed test. You must be able to identify type 1 and type 2 error. You must be able to interpret what is statistically significant and what is not statistically significant. So let's start by talking about what is hypothesis testing. A statistical procedure used to make decisions about population based on sample data is hypothesis testing, to determine whether the observed differences are real or due to chance. For instance, if we want to check whether the students that are doing after school activity are better off than those that do not, we need evidence. A particular activity or task will be given to the two of them. So basically, hypothesis testing gives us an opportunity to make an evidence-based conclusion. It helps us to reduce subjectivity and increase objectivity, and we are able to evaluate claim, test the effectiveness of an intervention, and research hypothesis. So let's start with the concept of null hypothesis. When we have a null hypothesis, it is assuming that there is no difference. A null hypothesis is assuming that there is no difference. That means between the two groups that we are carrying out research on. For instance, if we say male students are not different from female, that's a null hypothesis in terms of their achievement. It is telling us that the first one and the second one, they are equal. No difference, no effect, no difference in student achievement, no effect of instructional method, no relationship between variable, no effect of a drug, no effect of a therapy, no effect of a counseling, to mention a few. Look at this diagram. You will see that there is a null hypothesis there. Let's say we bought 2 sacks of tomato. sac A and sac B. Before we start counting, we can make an intelligent guess that there is no difference between the number of potatoes in sac A and sac B. So we will now count to see whether the numbers are equal or they are unequal. That is the meaning of a null hypothesis. Next to this is the alternative hypothesis. This alternative hypothesis assumes a difference or effect exists. So unlike null hypothesis, which is testing, which is assuming there is no difference, an hypothesis is an intelligent guess. The alternative hypothesis, on the other hand, is speaking to the fact that there is no difference. There is a difference. And it is possible that it is a two tail or one tail. For instance, we can say a new teaching methods improves achievements. Technology enhances learning outcome. Variables are significantly related. So, for instance, now, the alternative hypothesis possible for this potato may be hypothesis 1. The number of potatoes in sac A is greater than the number of potatoes in sac B. So another alternative hypothesis is that we can hypothesize that the number of potatoes in sac A is less than the number of potatoes in sac B. These two forms are the alternative hypothesis that is speaking to the fact that there is a difference, although the direction of the difference is not known yet. But it is very important to speak to the fact that there is an alternative hypothesis which we will begin to work with and think about. The next is the two-tailed test, which is called non-directional test. This two-tailed test predicts a difference between two groups but does not specify the direction. Look at this. This alternative A hypothesis and alternative hypothesis 1, they are telling us there is difference. But one is giving us one direction, greater than. The other one is giving us the second direction, less than. So in testing, we always call the one that is just giving us one direction, one tail. That means we are just checking a unidirectional thing, that male students will score better than female, or male students will score less than female. They are unidirectional. But when we call something a two-tail, it is not directional. It won't tell us A will be greater than B. Neither will it tell us A will be less than B. Rather, it will tell us that A and B are different, that there is a difference existing between them. And the difference can be negative, it can be positive, it can be less than, it can be greater than. So two-tail accommodates the two directions available while testing. Male student can score higher than female, they can score less. But the two-tail testing gives the opportunity. And that's why when you see the graph, the normality distribution graph in a two-tail testing, there are two areas that are shaded, and the place of our probability is also 2. There are 2 places where we could determine the probability in the 2 areas. That is, the rejection region is in the two-tail. So we have two-tail rejection region. So when the direction of effect is unknown, That's when you use the null hypothesis. That means within your thinking, you are not certain where the result will get to. So you can say there is a difference between the group. You are not saying A will be greater than B or B will be greater than A. So another one here is the one-tailed, which we call directional test. In this one testing, the difference is directional. There is a way we want it to go. And I've given example that these two are example of one-tailed test. These two here, the one on alternative hypothesis, SAC A will be greater than, and the second one of less than, they are speaking to the one-tailed testing. You know, the mean of the sample will be greater than or less than the mean of the population, as well as the other direction that we have provided. For instance, now, let's say a group of students are doing after school assignment, and I want to state my hypothesis in a way that it will be a one-tailed test. I will say those who participated in the after-school program will have a higher achievement score compared to those who did not participate. That is one direction. Or I may say those people that did not participate will have a lesser or a higher. I'm already specifying the direction of testing. And the rejection region and acceptance region is just one in that instance. But when I want to say the two-tail, I will just say that there is a difference between those people who participated in the after-school activity and those people that did not participate. So that difference may be negative and it may be positive. It can be greater than and it can be less than. So in summary, we can have the following. When it is a one-tailed test, the direction predicted in one tail, yes, but in two tail, no direction is predicted. The rejection side region in two tail is in one tail is one side, and in two tail is two sides. I had already showed us the graph. The statistical power in one tail is higher than while the other two tails is lower. The hypothesis statement for one tail is that this mu is greater than m1 or mu is greater than m1. These are the way the hypotheses are stated in this particular one. But this one, for two-tail, we will just say mu, there's a difference between mu and m2 in a null hypothesis statement. So this is how we usually test an hypothesis. We can test it the one-tail way or the two-tail way, depending on how the hypothesis is stated. Now, let's talk about errors. You know, we have type 1 error and type 2 error. Let us assume that the students who were given after school assignments did not really benefit from the activity, did not really benefit from the activity, and they guessed to pass the test. You know, I gave a test to a group that did after school. I did not give to the group that did not do after school. I gave to the group that did both groups, the people that did after school activities and those that did not do after school activities were given the same test, you will notice that the group that has a highest score is always considered the group that is working. But at times, that higher score, let's say we have two, higher, three is the highest. The group with the higher score, let's say we just have two, is actually responding not to the treatment conditions, but maybe to guessing and some other extraneous variable. And we now claim that there is a difference when there is actually none. That is called type 1 error. Concluding a strategy work when it actually does not work. It is type 1 error. And type 2 error is when you fail to reject a null hypothesis which is actually false. This one, we are rejecting a null hypothesis when it is true. Concluding that there is no difference between the groups when in reality there is. Imagine somebody going to the clinic and the doctor said that you have no cancer after testing him or her. And the person ran with that impression that he has no cancer. And actually he has. That is type 2 error. Because it is a dangerous thing. Look at the type 1. It is what we call false alarm. The person is told by the doctor after diagnosis that he has cancer, and he actually does not have. He actually does not have cancer. So that particular case is always referred to as the type 1 error. And it is good to ask which of them is more dangerous. Type 2 is more dangerous, and that is why the probability value in medical sciences, in engineering, is always set at 1%. It means that that very low probability value makes them to avoid what we call type 2 error. It's a dangerous thing for somebody to have cancer and you say it does not have, But in education, we always run away from type 1 error. That means we don't want to conclude a teaching strategy works when it actually does not, or a group have differences when actually they are not having differences. Because of this, I will illustrate better with the image here. Let us assume that we have this potato sack. Sack A, there is no difference between the two of them, and sack B. But when we did our counting, we made error in counting. We said potato, sack A, 43 potato. Sack B, 45. We now say there is a difference. Claiming there is a difference when there is none. So that's a false positive. In this other one, in reality, there's actually a difference. And we now claim that there is no difference when actually there is a difference. You can see that is false negative, claiming there is no difference when there is one. I said this second one is always avoided in the medical and engineering. We always try to avoid this in education. And to avoid this in education, we always set our statistical significant value at 0.05. What does this probability value actually means? It simply means that if our research were to be replicated 100 times in the same setting, under the same condition, we only want we must get that result that is we are getting 95 times. The other 5 times we attribute it to error that could be type 2, type 1. We don't want our p-value to be greater than 5. It could be equals to 5. It could be less than 5 to reject our null hypothesis. Let's say our null hypothesis is that there is no significant difference in male and female score. When we check the p-value on our table and that p-value is 0.05, we reject the null hypothesis. If it's less than 0.05, we reject it. But if it is greater than 0.05, we know that there is no difference. So in order not to fall into type 1 error, we reject it. But in medical sciences, their own is 0.01. And they usually fail to actually they run away from the type 2 error more than the type 1 error. So, and it is also important we pay attention to our sample distribution when considering these errors that are associated to our studies and research work. Thank you for watching the video, and we will love you to actually like and subscribe to this channel, share with friends. You can send us an email on the email address that is displayed on the channel. Thank you.